Hi everyone, so we're going to be looking at condensation reactions here. Sorry about that, the bell is just going. Okay, so as we look at condensation reaction, this occurs when we have a hydroxyl group and water, hydroxyl group and water that are removed and released as H2O, which is water. And when we look at organic compounds such as esters and ethers, they are formed from condensation reactions. So we're going to be looking at both of those now. So first off is esterification. So we looked at this previously. So we looked at forming esters, and we said that when we have esters, they can go through a reverse process of esterification, and that's where this is now. So we have a carboxylic acid and an alcohol, and it reacts to produce an ester and H2O. And this is also known as a condensation, which is what we're looking at now. So when we look at esterification, it is a reaction between carboxylic acid and an alcohol using an acid catalyst as well as heat. So those are two important points that we need to add, because that means when we have our arrow to show the reaction, those two things are going to be used. So when we look at a carboxyl group and we look at the acid, it's going to lose the OH group, and then the alcohol is going to lose the H atom. So when we look at this, this is always going to form water as a product. And the following example is obviously showing that here. So we have our carboxylic acid, we have our alcohol, they're removing the OH and the H from both of them. Do note only the hydrogen is being removed from the alcohol, and our hydroxyl, our OH is going to be removed from our carboxylic acid. It reacts to produce an ester, which once again, do note that we have our arrows both directions, because esterification, we can have it in reverse, and then we also create water. So an example here, we have 2-hydrobenzoic acid and methanol. Once again, you can see the parts of it are going to be removed from each of them to produce our methyl 2-hydroxybenzenate and our H2O. Another example that we can have is acetic acid as well as ethyl alcohol. It comes together to produce our ethyl acetate ester, my goodness, as well as H2O. So based off of this, we know we're going to have our catalyst, which is our esterification. We know we're going to produce H2O. So our acetic acid, as always, we have our COOH, and then on our carbon, we have our CH3. This reacts with our ethyl alcohol. So our alcohol always is OH with our CH2, CH3. This reacts to produce now our ethyl acetate. So once again, we have our OH and our H that is going to be removed, and the remaining is going to be combined together. So we have our CO, and then we add our extra O from our alcohol, and then we have CH2, CH3. So once again, we remove our hydrogen and our hydroxyl atom from both, and we are able to combine and create water. So do work through this synthesis of esters activity if you wish, as well as there's a way to check your understanding. So showing the esterification of hexonic acid and ethanol is going to be a great way to check your understanding of esterification. So do check that out now. So pause, check out your worksheet, and check that out now. Part B here, oh, I just realized this is all filled in. That's fine. We will just erase some parts here. We're just going to erase all of this. We'll just leave the blanks. Okay, so for B, we have the formation of an ether, which is an alcohol and an alcohol combined together, and it creates an ether. So once again, it's 2 alcohols, and we have the presence of sulfuric acid as our catalyst. So we have an example here where we have two alcohols that are going to be reacting to produce and dissociate our hydroxy and our hydrogen to produce water, and then also produce our ether. So in the example here, I'm going to give you an example, and then you are going to name the alcohols and the ether that is formed. So we have CH3, CH2, 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 OH plus OH, CH2, CH2, CH3, and this reacts to produce CH3. It's two. Oops. We're just gonna write this down here. CH2, CH2, CH3. We ran out of room. Plus H2O. So I want you to label it now. Try to solve for what the answer is. Pause now, try it out. Okay. All right, so check your work, make sure you named it properly. Once again, same sort of steps that we've taken in the past, so please do check to make sure you got that correct. And then the last part here is a formation of an amide. So we have our carboxylic acid and our amine, it reacts to produce an amide. So when we look at the condensation reaction here between the carboxylic acid and our amine, we do note that the hydroxyl group and the carboxylic acid are going to detach itself from the parent, and it's going to react with the hydrogen that was bonded to our amine. So you can see here, this and this is going to be removed to create water. What is left over from our NH2 is going to be joined and bonded to our original carboxylic acid that has now removed itself from that OH, our hydroxyl group. So I want you to make sure you understand that. I do want you to try out this reaction here between ethonic acid and propan-1-amine, which produces N-propylethane amide and water. So I want you to try that out, see what you can produce. Once again, you know water will be produced, but how will your amide look? So pause now, check this out, check your understanding here, and then let me know if you do have any questions. I will be posting the answer to this response.